Okay, now we're taking a look at number 11, which has 4 parts to it. When that happens, I like to draw a graph, a separate graph for each part, even though it's the same function. So I've got radical x, y equals 0, x equals 3. So I see my region. And for part A, we're going about the x-axis. So I'm going to draw my rectangle perpendicular to the axis of revolution. Pi, oh, I already put 0 to 3. Big R is the distance from the axis to the far end of the rectangle. Little r in this case is 0, which means we have a disk. So it's pi times the integral from 1 to 3 of x. And this one I'm just going to do by hand instead of putting in my calculator. So I've got 1/2 x squared from 0 to 3. I'm not going to substitute the 0, just going to plug in the 3, and I get 9 pi over 2. So that was just part A. Now we have part B. So again, same function, same region, but this time we're going around the y-axis. So our rectangles are going to change their orientation, and they're going to be horizontal, perpendicular to the axis of revolution. Okay, so now volume equals pi integral a to b big R minus little r dy. So pi, and instead of 0 to 3, we're going up to radical 3 because the function is y equals radical x. Big R is the distance from the axis of revolution to the far end of that rectangle. That is always going to be 3. And then little r is the gap. It's the distance from the axis to the closer part of the rectangle. And that is given by the function. But we don't want it in terms of x. We want it in terms of y. So it's y squared squared dy. So if you put this in your calculator, you'll either get an exact value, which will give you 36 pi radical 3 over 5, or in decimal form, you can leave your answer. Remember, you want at least 3 decimal places. So that would be 12.47. I'm going to round to 1, and then I'm going to put the pi in there. Part C. Okay, it's not one of the axes now. We've got y equals radical x. Here's our region, but we're going around the line x equals 3. So our rectangles we still draw perpendicular. So they're horizontal. Everything is going to be in terms of y. So pi, 0 to radical 3 again. Big R is the distance from the axis to the far end of the rectangle. That was really sloppy. Let's try that again. There we go. That distance is going to be that entire distance of 3 minus our y squared. Remember, this is really y squared. Minus r, which is the distance from the axis to the closer end of the rectangle, and that distance is 0. Okay, so one more time. Big R is the distance from the axis to the far end of the rectangle. That's going to be 3 minus the function here, and then we get our r. We're going to put this in our calculator, and we're going to get an exact value of 24 pi radical 3 over 5. Or we can write that in decimal form. I'm going to round to 3.13. Remember, you want at least 3 decimal places, and then there's our pi. Part D. Same region, but now we're going around the line x equals 6. Draw your rectangles perpendicular to the axis of revolution. Everything is going to be in terms of y. All right, and here we go with the fun part. We're going to have pi. These are y values, so we're going from 0 up until here where the region ends, not over here, but here, which is going to be radical 3. Now, big R is the distance from the axis of revolution to the far end of the rectangle. So from here to here. Okay, that distance is going to be the entire distance, this whole thing, which is 6, minus what the function gives us, which is y squared, minus, change colors here, the distance from the axis to the closer end of the rectangle. That's our little r, so that creates the donut hole. And that distance is always going to be 3. It's the distance from 6 to 3, which is 3. Okay, I'm going to simplify this a little bit. So 0 to radical 3 squared minus 3 squared dy. And the exact value is going to be 84 pi radical 3 over 5. Or as a decimal, you're going to get 29. Remember, you need at least 3 decimal places. 0.98 pi. Okay, 13 is very similar. We've got just an A and a B, though. Changing the axis of revolution. Now they give us 2 functions. But no graph, no limits. All right, so let's see. Let's find where these intersect. So I'm going to have x squared equals 4x minus x squared. So I get it 0 and 2. So then for part A, I know I'm going from 0 to 2, so I'm just going to look at the first quadrant. F of 0 is 0 for both of them, right? And then f of 2 is going to be 4. So we have just our y equals x squared. It's going to be a parabola up like this, and I'm going to change colors. This has a negative leading coefficient, so it's going to turn down, okay? So it's got to go through these points. Oh, that is a funky looking parabola, but that's what we're going with. So it opens downward. And then for A, we are going about the x-axis. So our rectangles perpendicular to the axis of revolution. We know we're going from 0 to 2. And big R is the distance from the axis to the far end of the rectangle. That's going to be our green. And little r is the near end of the rectangle to the axis of revolution, which is our red. We could do this by hand, but I don't really feel like that. But we're going to get an exact answer of 32 pi over 3. Okay, let's check out part B. I'm going to try to draw this graph again, but a little bit better. This is 2 and 4. So 0, 2, 4. So we've got our y equals x squared. And then our other parabola that comes, oh, that's so much worse. So much worse. Okay, it's slightly better. Okay. Part B is telling us, oh, to go around the line y equals 6. So that's like all the way up here. Tricky, tricky. All right. So here's our rectangle perpendicular to the axis of revolution. Pi 0 to 2 of big R minus little r. Pi 0 to 2. Big R is the distance from the axis of revolution to the red. So that distance is going to be this whole distance, which is 6, minus the red, which is x squared, minus little r, whoops, which is not that, which is the distance from the axis of revolution to the closer end of the rectangle. And that now is going to be the whole distance and then minus the green. So here we go. So the whole distance minus the green. And I'm going to change distribute the negative there. And then that gets squared. This, we have to be very careful when we put that in our calculator. So 0 to 2. And we're going to get, oh, I don't need to rewrite this. Put that in the calculator, and we're going to get 64 pi over 3.